Hello, everyone. Welcome to this new episode of Armstrong live stream series. My name is Rossen. I have been with Armstrong for 25 years, and I'm the managing director for Europe, Middle East, and Africa. And today I'm sitting in our learning center in Belgium in front of some glass models of steam traps, as the subject of this episode is steam trap management. I'm very pleased to welcome our guest of today, Béatrice Majouki, who is the Global Energy Manager for Arkema. Béatrice, could you tell us a little bit more about yourself and about Arkema?
Yes. Hello, Rossen. My name is Béatrice Majouki. I've been working for 37 years at the company which became Arkema in 2004. I did a different job, production manager, process manager, project manager. What about Arkema? Arkema is a major player in specialty materials with a global presence in 55 countries, 141 industrial sites, 60 in Europe, 39 in North America, 40 in Asia, and the rest of the world. In 2021, 20,000 employees were working for Arkema, and the company sales were about 9.5 billion euros. The ambition of Arkema is to be the specialty material leader, offering the most innovative and sustainable solution to address our customers' current and future challenges, partially related to decarbonization. I've been in charge of the energy saving initiative of the group at the worldwide level since 2013. We have a very ambitious objective to improve our energy efficiency of our plants by 25% by 2030, relative to 2012. That is to say, to manufacture the same quantity of product with 25% less energy.
Yeah, that's an impressive goal indeed. 25% energy efficiency. These days, energy is in the news all the time. We are all impacted by the energy situation in our daily lives. But can you tell us a little bit more about the specific context in the chemical industry? How important is energy to a chemical company?
Yeah, energy is a significant part of cost of production. For Arkema in 2014, it represented 10% of the variable cost. Currently, with an improvement done during the last 7 years, energy represents 6% of our variable cost. Nevertheless, due to the significant increase of energy cost globally and the question about energy availability in Europe, energy has become now a business risk. The less primary energy we consume, the more limited this risk is.
Yeah, indeed. Many companies start to realize now that energy is no longer a commodity which is cheap and easily available. And many people are focused on reducing energy consumption on the very short term. Now, beyond these challenges, on the longer term, the focus is increasingly on decarbonization. So what are the Arkema goals for decarbonization by 2030?
After reducing by more than half its greenhouse gas emission over the past 10 years, the current target of Arkema is to reduce the greenhouse gases emission scope 1, 2, and 3 by 46% by 2030 relative to 2019. For scope 1 and 2 only, this is the equivalent of 1.7 million tons of CO2. This target is in line with the Arkema's climate commitment to contain global warming to 1.5 as per the Paris Agreement. This decarbonization target is based on the evolution of the energy mix of Arkema's plant. We plan to increase our green energy procurement and to continue our energy efficiency program. This program is supported by a dedicated financial budget for energy saving investment. We are also applying an internal price of CO2 of €100 per ton at worldwide level. The energy efficiency of Arkema's industrial activities has already improved by 15% compared to 2012. And our group is looking to further raise this gain to 25% by 2030.
Yeah, that's interesting because what you just mentioned about the internal carbon price, which is used to fund energy efficiency project, that seems to be working quite well for a few companies to progress and achieve their net zero goals. Now, a little known fact for the outsiders is that beyond the fossil fuel consumption of most industrial companies, there are actually steam systems. So fossil fuel, such as natural gas especially, is being burned in boilers in order to generate steam. And this steam is used either for heating or it is used to do some mechanical work. Can you tell us why you decided to create a program on steam trap management?
Yeah, Rossen. In fact, most of our energy consumer plants use steam, and also they have a lot of steam traps, which have an average time life of 5 to 6 years. When a steam trap is leaking, it causes an energy loss. When the steam trap is blocked, it can disturb the production, and operators might react to this by opening bypass or drain valves, causing again an energy loss. So the replacement of the failed steam trap has a payback of only a few months. This is why steam trap appear often in our quick win projects. From energy perspective, it is important to have a regular maintenance program for the steam trap population to maintain the failure rate as low as possible. In fact, by analyzing a few years ago the results of the steam trap surveys of a sample of our plants, I realized that steam trap testing and replacement was not done systematically. The failure rate was very variable depending on the plant. But in average, it was around 20% and more. It's very high. In fact, there were different reasons for that. First reason, a failed steam trap does not necessarily prevent the plant from producing. Even if it results into a loss of energy, its repair is not considered as urgent as the maintenance of process equipment. The second reason, sometimes the repair of a failed steam trap needs a complete shutdown of the steam trap system. Indeed, steam traps cannot be isolated easily if there are not if there are no shut-off valves before and after the steam trap to be able to do the repair safely. The specificity of some of our plants is that they operate continuously. Steam system shutdowns for maintenance are scheduled sometime once a year and sometimes once for 2 years or 3 years. So not very often. And so during this time, we have steam losses and energy losses. Therefore, we decided to tackle these issues by creating a new global program focused on the regular maintenance of steam traps. The objectives of this initiative are, first, to raise staff awareness of the maintenance of their steam traps. The ones detected as failed have to be repaired or replaced immediately. A change of culture. Second, to make all steam traps, starting with the critical ones, easy to isolate in order to repair them as soon as they fail.
Yeah, you're raising an important point, Beatrice, is that steam traps are often considered to be a maintenance subject. They need to be taken care of by the maintenance department. But if the failure is left for a while, they become an energy issue and an environmental issue. Based on our experience, failed steam traps can generate an excess of energy consumption of 2 to 3% of the steam being generated, and this also obviously results into useless CO2 emissions. Can you tell us what is the current coverage of your program?
Yes, currently our program includes around 14,000 steam traps worldwide. The program started almost 3 years ago in October 2019. Arkema signed a 3-year contract with Armstrong for all our European plants. It represents 26 sites having around 10,000 steam traps. This contract included yearly steam trap surveys for all our European plants, the steam trap management software called Sage, and the handheld testing device called UMT. And the objective of this program was to reduce steam trap failure rate from 20% to 7% in 3 years. The program has been extended to Asia and to America in 2020 and 2021. It now covers more than 90% of all our steam traps globally.
Thank you for your trust, and we are really grateful to have been working with you. Can you tell us why did you select Armstrong as your partner for this program?
We were looking for a global partner who could work in all our plants in Europe, in Asia, and in America. First reason. It was also very important for us to be able to follow the results of the steam trap surveys. And the SAGE reporting tool is a real lever of improvement. It allows to know the situation at any time in each plant. Moreover, the UMT allows our site to test steam traps themselves between the yearly survey done by the Armstrong. And eventually, we will be able to carry out preventive maintenance on steam traps.
Yeah, so we are now 2.5 years after the beginning of the program. You mentioned end of 2019 as the starting point. What are the results achieved so far? Can you give us some numbers?
I'm very proud as since 2020, the steam trap average failure rate has decreased by 33%. Our main pilot sites have already achieved the failure reduction goals expected at the end of the program. We have already reduced our energy consumption by 57 gigawatt-hour in 2021, resulting into a decrease of 10,500 tons of CO2. Our total investment has been about 2 million euros with a payback of about 1 year. This includes the installation of complete valve station. This allows the isolation of steam trap at any time.
Yeah, these are impressive results, impressive achievements. So how do you see the future? What would be for you the next steps of these programs?
We have to continue. We will continue the approach on adding double isolation trap valve station. They allow the safe replacement of steam traps outside of a shutdown period. Very important because the shutdown period is a period where maintenance guy have a lot of work. We can then plan to install continuous monitoring devices. This equipment will detect failures in real time on the most critical steam traps. This will allow us to shorten the time between failure and replacement due to the faster detection. And thanks to such a story, we will also be able to analyze the time life of certain critical steam traps, and why not to start to do preventive maintenance on them.
Thank you, Béatrice. I'm really happy that you were able to share with us your feedback, because your program is really a best in class in the industry. Indeed, we do see many companies working on that subject, and most of them are really applying a stop and go approach to steam trap management, when in reality is more of a continuous improvement project, as you just described it. Continuous improvement requires a kind of step-by-step approach, which identify the next bottleneck, preventing from eliminating these losses, or reducing these losses, or limiting them in time. And when you apply stop and go approach, when you stop, typically the failure rate comes back within a year or two to the historical levels. So really, steam trap management is much more of an organizational project than it is really a technical challenge. So your insight after almost 3 years in this program were really interesting, and I hope they were useful for the people who have to deal with the same subject in their companies. Thank you again for your time, Béatrice.
Thank you, Rossen.
And thanks to our viewers, and for those who did not see the previous episode of Armstrong Livestream, please go to our YouTube channel, or you can find more information on our website, armstronginternational.com.